Hi everybody and welcome to this new video. Today I will explain how to enhance a real-time multiplayer game built with Amazon GameLift and Unity 3D with generative AI. In this video we are going to talk with NPCs. Lately I have published a series of articles and videos about building a real-time multiplayer game with Unity 3D and Amazon GameLift. I also enter the AI field and produce content about integrating Unity 3D and AI services, ChatGPT, DALL-E, Amazon Recognition, and Amazon Bedrock. On my video about Amazon Bedrock, a clever follower left this comment. This could really open up some cool NPCs interactions. That's an amazing idea. Technically, it would be a perfect mix between my work about Amazon GameLift and the one about Bedrock. Thanks for the ID MacLeod6235. Let's do it. Before beginning the implementation, let's have a quick remember about what an NPC is. A non-player character NPC, as its name indicates, is a character that is not controlled by a player but can eventually interact with the real players of a game. Therefore, every action or decision taken by the NPC is server managed. This is very important. This is a cloud architecture we will build in this video. It contains three parts. A simple architecture of a real-time multiplayer game implicating the services Cognito, Lambda, and GameLift. A Lambda function that calls the generative AI service Amazon Bedrock, and a connection between GameLift's game server and the Lambda function. For the first part, please refer to my YouTube playlist about Unity 3D and Amazon GameLift. And for the second part, to my video about Unity 3D and Amazon Bedrock. This video will focus on the last part, how to invoke a Lambda function from a GameLift game server. Remember that an NPC is server managed, therefore everything will be done from the game server. Now we want the game server to access another AWS resource, here Lambda. The classical way to do it would be to create a role with associate policies to allow GameLift to invoke a specific Lambda function. But this is an uncommon case and it requires an extra step. The GameLift documentation tells us the following. If you want to connect your game server to other resources, you have to follow those steps. First, set up an IAM service role for Amazon GameLift. Then associate the service role with your GameLift fleet, and this is the extra step. You need to add code to your game server to assume the service role and then call the service you want, in our case Lambda. Why this extra step? GameLift game servers are actually composed of one or multiple EC2 instances called a fleet. Therefore, we must associate the role to the fleet and also to the EC2 instance where the game session is running. Okay, now we are ready with the theoretical knowledge. Let's start the implementation. I recommend you fasten your seatbelts because this won't be straightforward at all. Let's go to the IAM console. We create a new role and we select GameLift as a trusted entity. We give a cool name and we create the role. Then we add an inline policy and we choose Lambda as a service. The only permission we allow is the invoke function permission for a specific function. In my case, NPC function. We give the policy a name and we create it. Our role is ready. This is the ARN of the role. We will need it in a moment. Now we can create a new GameLift fleet and associate the role during the creation, but we won't do it yet because we need to work first on the extra step, which is assuming the role from the game server. Remember that when you create a new fleet, GameLift automatically creates and manages a new game server for you. However, you can define what will be the behavior of the game server thanks to the Realtime script, which is basically a script you attach to the fleet during its creation. If you want to know more about the Realtime script, please refer to my previous video about it. This is the Realtime script. This script is written in JavaScript, so the first things we are going to do is to import the AWS SDK for JavaScript. Just a side comment here, I was not able to work with version 3. It made my game server crash. With version 2, everything worked like a charm. So we import the SDK version 2, and when the game session starts, we assume the role we have created before. To do it, we call the security token service, STS, and we indicate the ARN of the role we want to assume. Once the role is assumed, we receive a set of temporary credentials, and we use them to build the Lambda client. Then, when a player interacts with the NPC, we invoke the Lambda function. In my case, NPC function. And we send back the result to the player. Please don't pause the video, you can find all the source code and packages in the description of this video. Okay, now there is something very important you need to know. The AWS SDK for JavaScript is not installed in the game server. So what we're going to do is bundle the script along with the SDK and upload it to GameLift. In your local environment, install Node from the official website, nodejs.org. Once installed, you should be able to enter the Node console by opening a new terminal or command prompt and typing Node. Okay. Then go to the folder containing your Realtime script and install the AWS SDK for JavaScript by typing npm install aws-sdk. Once installed, we check the folder and we have the Realtime script and the dependencies. Then we zip the folder and we are finally ready to upload it to GameLift. Go to the GameLift console. In the script section, create a new script. Then we upload the zip file we have just created. And we have a problem. Our zip file is too big. The reason is the following. AWS SDK for JavaScript version 2 is not modular. So we had no choice. We have installed and zipped the whole SDK. With version 3, we could have installed only the services we need, STS and Lambda. And this would have resulted in a lightweight zip file, 2 or 3 megs. Hopefully another option is available, hosting our zip file in an Amazon S3 bucket. This is our new and unexpected architecture. We are going to host the zip file in an S3 bucket and create another role to allow GameLift to access the bucket. Go to the S3 console and create a new private bucket. We upload the zip file containing the Realtime script and the dependencies. Then go again to the IAM console and create a new role. We select GameLift as a trusted entity. We create the role and we add a new policy to the role. we select the get object permission and we indicate the bucket and the file we want to give access. We give a name and we create the policy. Now go back to the GameLift console. We can upload our script and dependencies indicating the role we have just created and the path of the file. Finally, we can create our fleet. Go to the fleet section and create a new fleet. Give it a cool name and select the script we have just created. In the additional detail section, we associate the role that allows access to the Lambda function. Then we select the region, the instance type. For the launch path, be careful. It says relative path within the zip file. Remember that this time we have zipped a folder containing the script. Therefore, the path will be, in my case, GameLift/multiplayer.js. We finish the creation of the fleet and we wait approximately 10 or 15 minutes for the fleet to be ready. And then let's go to Unity. This is my Unity client. Again, don't worry about the source code. You can find the Unity package of this application in the description of this video. I have another Unity client who will witness everything. I'm looking for the NPC, here he is, and let's talk with him. How are you today? Wow, I'm doing great. So it's working great. Let's ask something else. What's your name? Stares silently with a stoic moe face. I like it. It's very deep and dramatic. That's it. Thanks a lot for watching this video until the end. I really hope that you liked it. If you liked it, please subscribe to my channel and follow me on my social networks. See you in the next video.